Alright, so returning to our subject, we have other circular functions as well as sine and cosine, and they basically combine the sine and cosine in various ways. So let's talk about that a little bit. Let's talk about tangent first. The tangent function, or abbreviated TAN, tan of S. S is the arc length on the unit circle again. Alright, and that equals the sine of S over the cosine of S. And written as coordinates, that would be the y value over the x value of that point. Alright, so sine over cosine is tangent, or y over x. We have cotangent, or abbreviated COT of S, is basically the inverse of that, the reciprocal of tangent. That's equal to 1 over tangent S, or you could write that as cosine S divided by sine S, or x over y. And there's secant. The secant function is 1 over the cosine of S. That's abbreviated SEC of S, is 1 over cosine, and that's cosine is x, so this is 1 over x. And then we have cosecant, abbreviated CSC, and again these are usually written as lowercase letters. CSC of S is equal to 1 over the sine of S, and the sine is the y coordinate, so that's 1 over y. So there are your basic circular functions besides sine and cosine, and they're all made from the sine or the cosine function. So if you know about sine and cosine, you can get the others easily. So let's find some sample function values using these. So for example, what's the tan of pi over 3, or tangent of pi over 3? Well, you have to know the sine and the cosine of pi over 3. If you remember, the point pi over 3 on the unit circle has coordinates 1/2 and square root of 3 over 2. Alright, so this is equal to sine of pi over 3 over the cosine of pi over 3. And that's equal to the square root of 3 over 2 over cosine of pi over 3, which is 1/2. So that's equal to square root of 3 over 2 times 2 over 1. You can cancel the 2's out, and you end up with square root of 3 over 1, or just square root of 3. Alright, so the tangent of pi over 3 is square root of 3. So you would do the other ones in a similar way. Alright. And we can also talk about negative angles as well. If you have a unit circle like this, a positive angle would be formed by going in a counterclockwise direction. You always start right there at the point 1, 0. And if you go counterclockwise, you're going in a positive direction. If you go clockwise, that would be this way, that would be a negative angle. And so if you, for example, have an angle of, or an arc length, remember the angle, the radian angle and the arc length are the same on the unit circle. So for example, if I wanted to go pi over 4 as an arc length, positive pi over 4, I would be right there. If I wanted to go negative pi over 4, I would be right here. So the tangent of, for example, negative pi over 4 would be the same as the tangent of 11 pi over 6, because that's positive 11 pi over 6. And so you would take the coordinates that you got from previous calculations and computations, and you would use the coordinates of that point to get the angle, or to get the tangent of negative pi over 4. All right. Now, since the trig functions, or rather the sine and cosine functions, depend on the x and y coordinates, in some quadrants you're going to have positive values, and in others you're going to have negative values. So, for example, in the first quadrant on the unit circle, both x and y values are going to be positive. So any point on the unit circle in the first quadrant will both be positive, or will have positive components to it. The x and the y will both be positive. If you're in the second quadrant, the y coordinate is positive, but the x coordinate is negative. Alright? So you've got a negative x coordinate and a positive y coordinate. And in here you've got both positive. If you're in this quadrant, the third quadrant, pick a point in there somewhere, it's going to be negative x value and a negative y value as well. And if you pick a point in the fourth quadrant, it's going to be a positive x value and a negative y value. So all the trig functions that are for arc lengths or angles in the first quadrant will always be positive. The sine is positive, the cosine is positive, and therefore the tangent, which is sine over cosine, would be positive over positive, which is positive. The cotangent is positive, the secant and the cosecant are all positive. Alright? Everything's positive in the first quadrant for those angles, that is. And if you're in the second quadrant, the sine will be positive, because that would be the y coordinate. That's positive. And cosine and tangent will be negative. Alright? In the third quadrant, the tangent will be positive. That's sine over cosine, which is going to be negative over negative, and that's, of course, equal to a positive number. And negative will be sine and cosine. And in the fourth quadrant, cosine will be positive, because that's your x-coordinate, and negative will be sine and tangent. Alright? Now you can use a grapher or a calculator to find values or trig function values of different angles. And on most calculators, if you have a grapher especially, or a scientific calculator, you'll have a choice between different types of angles. For example, on this one, this is an older one, but I can choose, if I go to my mode section, now yours might be a lot different from mine, but they all have essentially the same ways of choosing these. You have a choice of different types of angles, like I've got DEG here, which stands for degrees, or RAD, which stands for radians. I've got RAD selected. When I do that, I've got a little 2 pi appearing up here. That means radian mode is selected. So all of the angles that I enter into this calculator will be considered to be radians. I can press this, and that'll give me degree mode, and the 2 pi disappears up there. Your calculator might indicate the radian or degree mode in different ways. I'll stick with radians for now, and we'll try some trig function values. Let's try, for example, the cosine of 2 pi over 3. So how do you do that on your calculator? Well, on mine, I would go 2 times pi divided by 3. So 2 times pi divided by 3. And then take the cosine. And I need a decimal approximation for this, so I have to go through a special procedure for that. And I'm getting